Okay, continuing on with some harder problems that involve implicit differentiation. I want you guys to go ahead and put this on your graphing calculator and graph these two graphs. I'm going to go ahead and tell you where their intersection points are just really quickly because those are the 2 points we're going to be looking at to figure out whether or not they're orthogonal. I'll explain orthogonal a little bit further here after I get their points of intersection. Again, you guys can use your graphing calculator to do this. I'm going to just do this visually by making a substitution. I'm going to say 2x squared plus 3x cubed. I replace my y squared with an x cubed equals 5. I can then see that at x equals 1, there's going to be some points of intersection. Those 2 points that you guys are going to see on your graphing calculators, or I can just do them by hand, are 1, 1, and 1, negative 1. What we want to do is at those points, we want to see if the tangent lines are perpendicular to each other. So we're going to see if the slopes of the tangent lines are negative reciprocals. So I'm going to take the first curve, y squared equals x cubed, and I'm going to find, in general, the derivative, meaning the slope of the tangent line, and this could be used to find it at any point. So I have 2y dy over dx equals 3x squared, and then I'm going to divide by 2y on both sides. That gives me 3x squared over 2y. That is the slope of the first curve at any certain point. The slope of the second curve would be found by finding its derivative of 4x plus 6y dy over dx. The derivative of 5 is 0. Solve for dy over dx. I have 6y dy over dx equals negative 4x. Divide by 6y on both sides. I end up getting negative 2x over 3y. I did reduce my 4/6. Now, in order to figure out if their slopes are negative reciprocals of each other, we need to actually figure out what is the slope at 1, 1 for each of these. So when we're talking about the point 1, 1, the slope of the first curve would be slope of first curve would be 3 times 1 squared over 2 times 1, or 3/2. The slope of the second curve at 1, 1, okay, would be this one. It would be negative 2 times 1 all over 3 times 1. So we get negative 2/3. Notice how these two slopes are negative reciprocals of each other. They are negative reciprocals of each other. And I can now say that these are orthogonal at 1, 1. We only need to check then at 1, negative 1. So when we're talking about the point 1, negative 1, the slopes of the first curve, the slope of first curve, we're going to plug in 1 and negative 1. So I'm going to have 3 times 1 squared over 2 times negative 1. This gives me a slope of 3 over negative 2. And the slope of the second curve, when I plug in 1 and negative 1, gives me negative 2. I'm plugging back in over here, plugging in 1 for x and negative 1 for y. That gives me a negative 2 over a negative 3, which is a 2/3. So again, we get two slopes that are negative reciprocals of each other. So I have shown that these two graphs at those intersection points, that the graphs are orthogonal at those points of intersection.